Hello, algebra students. Mr. Laurence here, and we're about ready to wind up this rad stuff, so we're going to do a little practice rad quiz. The real smart student that cares about their performance will not watch me do these problems. They'll pause the video and try to do them themselves, and then see if they match. Because I heard a little rumor that Friday we might be having a quiz. I heard that rumor. I don't know. It might be true. It might not. All right. Woe is me to those of you that don't watch the videos. Oh, dear. Oh, dear. All right, well, hopefully you've paused and already tried problems, maybe 1, 2, and 3. Maybe you can't see 3 well enough. If you like, I'll do that for you. There's 3 and 4. Okay, I'm getting ready to do numbers 1 and 2 here. I'm going to simplify this. I like to break down the number inside the rad into a perfect square if I can, into factors that have perfect squares, I should say. So I'm going to think about rad 90 as 9 times 10. 9 is a perfect square. 10 is not. There's no perfect square factors hiding inside of 10, so I'm not going to worry about it, but I'll worry about 9 being 3 times 3. And look at that, I can pull a pair of 3's out on one date, and then there's a 10 left. So rad 90 simplified is 3 rad 10. Now, by the way, I could check my work. I could square 3 and get 9, and then multiply by 10, and then, of course, I get 90, and that's a way to check and see if I did it right. All right, you'll be expected to simplify if we have this quiz tomorrow. All right, number two, we have to add and subtract. Well, of course, we know that we have to have like terms. And I have a rad 5 and a rad 45 and also a rad 2. So it doesn't look like I have any like terms here, does it? But I can simplify the rad 45. So I'm going to have a 2 rad 5 plus, let's see, that's going to be a 9 times a 5. So I think that's going to be a 3 rad 5 minus a 5 rad 2. And when I combine these two terms, I'm going to get 5 rad 5 minus 5 rad 2. Now, they're not like terms because this number tells me how many of this there are. There are 5 rad 5s, and I'm taking away 5 rad 2s. For them to match, the rads would have to be the same number. So there is the answer after I simplify, after I do my addition and subtraction. All right, 3 and 4, let's take a look at those. If you haven't tried them yet, go ahead and pause. Here comes my solution. Number 3 is simple. Multiply 5 times 3 and get 15. Now, pay attention to this. A lot of you do this, but some of you don't. I saw some of your video quizzes where you weren't doing this. You were wasting time on multiplying 7 times 14. I'm not going to do that at the moment. I'm going to write down the 7. 7's prime. It doesn't have any other factors other than 1. And 14 is not prime, but it has a factor of 7. So I'm going to write down 14 as 7 times 2. Well, I've got these two 7's here, all right? And I'm going to do 7 times I'm going to bring the 7's out of the house. So out in front of the rad, I'm going to have a 15 times a 7. Now, who's left inside? A 2. Now I can do 15 times 7, which is going to be 105. And so my best answer is going to be 105 rad 2. All right. Okay, we've got to multiply number 4 again. If you haven't tried it yet, pause the video. It's a double distribution, so I'm going to multiply 6 times 5 and get 30. I'm going to multiply 6 times 3 rad 4. Well, that's going to be 18 rad 4. All right, I'm going to multiply here and get negative 5 rad 2. And then I'm going to multiply here and get a negative 3 rad 8. Now, hopefully some of you caught something. Some of you are like, hey, Mr. Lawrence, this can be simplified more. You're kind of doing this the hard way. Yes, I am. I'm showing you that if you miss simplifying first, I always like to simplify first. Like I would have simplified this first. Okay, and I'll do that in a minute. I'll show you how I would have done it. It'll make this problem so much easier. But since I didn't simplify first, I'm going to come in here and simplify. I know rad 4 is 2. So this is 18 times 2. So I really have 30 plus 36. Now I have a minus 5 rad 2. But this simplifies. 8 is 4 times 2, and rad 4 is 2, so this is minus 6 rad 2. So I didn't really think I had a lot of like terms. All of a sudden I have a bunch of them. I have 66 here, and then I have minus 11 rad 2. I think this is the hard way to do it, but it can be done this way. All right, let's go back and see an easier way, or potentially a way with less work. All right, before I actually get to the double distributing, I notice right off the bat that this can be simplified. This is going to be a 2 outside the house, and so that's going to be a 6. So my problem is really 6 minus rad 2 times 5 plus 6. Well, the order of operations tells me I can add these two, so that's 11. So my problem is really going to be just a simple distribution, 66 minus 11 rad 2. I don't know about you, but that way it was so much easier. All right, look for things like that. All right. Let me see here. Here's two division problems. Okay, go ahead and pause the video. Well, I know that dividing two rads is the same as the rad of a quotient. Let's see, this would be 80 over 2. And so therefore, this is the same as rad 40. Now 40, let me see here. I'm thinking 4 times 10, and 4 is a perfect square, so this should equal 2 rad 10. And there is your answer. All right, over here I'm going to have the rad of 50 over 100, which is the same as the rad of 1/2, which is the same as the rad of 1 over the rad of 2, which is the same as 1 over rad 2. All right, some of you could have gone right to that, but I never leave a rad in my denominator. So I have to rationalize my denominator. I'm going to multiply by rad 2, multiply by rad 2, and I'm going to get rad 2 over 2, and there you go. All right, let's try number 7, 2 rationalizing the denominator problems. Go ahead and try them on your own. Problem number 1, I'm going to multiply by the irrational part of the denominator. I don't need to multiply by the 6, I'll just have to simplify later if I do. And so I'm going to get a 5 rad 3 in my numerator. And rad 3 times rad 3 is going to be 3. 3 times 6 is 18. Nothing else will simplify. There we go. That is the equivalent form of this problem, but the denominator is rational, and that's very important. All right, number 7, I'm going to use that difference of perfect squares idea, and I'm going to multiply by this. So in the numerator, I have to distribute, and so I'll get 21 plus 3 rad 3. The denominator is going to be it's going to double distribute and look like a difference of perfect squares problem. So I'm going to get 49, and over here I'm going to get a minus 3. Now this is a negative 7 rad 3, and this is a positive 7 rad 3, so they're going to cancel. So all I have left to do is simplify my denominator a little bit. 21 plus 3 rad 3 over 46. Now, one thing you want to be careful of, always want to be on the lookout. If this was a multiple of 3, there'd be one more step I could do. Let's pretend just for a moment that I got 21 plus 3 rad 3. I see a GCF here. Let's pretend this was over 49. It's not over 49, but we're just going to pretend. In the numerator, wait, not 49, excuse me. 49 is not a multiple of 3. Let's do 48. Yeah, let's do 48. Okay, so if I factor out a 3 in the numerator, I get 7 plus 3 rad 3. It's like I never distributed, right? Okay, and then I have a 48 here. This is multiplication. This is division. 3 could go into 3 once, go into there 16 times. So the best answer, if this were the right work would be this. But here, I did get 46 correctly. Yeah, 3 is a GCF, but 3 does not go into 46 evenly. So this is the correct answer. All right, that's it for the video for May 7th. Mr. Lawrence signing off. Have a good night, everybody.